This video is a tutorial question that is, I don't know where is it, but the lecturer just gave you. So it deals with the sandwich composite. You can start off by understanding them with these 7 videos from lecture 7 onwards. Alright. So after, if you happen that you finish understanding it, then you can try out the tutorial 7.8. Alright, all the way to here. Yeah, I think here. Yeah, okay. So 7.8 onwards, these are all the tutorial questions that deals with sandwich composite. So in this video, we'll also be dealing with sandwich composite. Okay. To start, I'll just start off with the question. I'll split this question into multiple videos. So in this video, I'll just introduce you with what are the things that is needed for you, and next we'll carry on with the calculation in the next video. Why am I talking like that? Anyway, so yeah, so consider a polyethylene foam of this particular thickness sandwiched between two steel facing plates. So the first thing when you start doing things, you need to visualize. So when you start to draw two since they are since you see that the polyethylene foam is sandwiched between, alright, so the polyethylene is over here, alright, and sandwiched between two steel plate. So you may want to draw it out, alright, and the thickness of this foam, alright, is 17.5 mm. Alright, maybe I should draw it clearer, so therefore I'll just bring in this diagram. Okay, this diagram is accessible to you in your textbook over here. Alright, page 70 in our lecture note part 2 composite. Okay, give me a moment. So this sandwich core, alright, is C, alright, we'll name it as C, which is 17.5. So I'll just simply write it down as C is equals to 17.5 mm. That you know that the polyethylene foam is this value. Okay, the thickness of your steel plate is 0.5 mm. Okay, so it's T, right? So you just write down T as equals to, alright, if a simply supported beam based on this sandwich construction has a span of 200 mm, alright, section width of 50 mm, subject to a concentrated load of 1.5 kN, what will be the body and shear stress distributed on the beam section? Then this is a bit hard to visualize, right? And therefore, alright, it spans 200 mm. Always take note that this diagram that you have just drawn is a cross-sectional, alright? So if you were to just draw it out, alright, I'll just extend. This is your cross-section. I'll just extend it all the way out, alright? This length over here is your 200 mm, okay? And your width, alright, your width, section width, your cross-sectional width, B, is 50 mm, okay? So you just need to know of this type of awareness that you should take note of. Okay. Since we know that the width B is equals to 50 mm, we can just write it down. And then nonetheless, you can also write the length as equals to 200 mm, which is not inside here, but you should take note of it in case that you need it in the later parts. All right. And subjected to a concentrated load of 1.5 kN. Be careful, it's kilonewton, so it's 1500 Newton load. Alright, so normally when you start to do this type of thing, you need to know or specify all this value. Okay, and moreover, this value like DH, alright, these are the things that you also need to take note of. Okay, so since we know C, we know T, and the rest, we can calculate our D and H. So let us just calculate our D first. D is the midpoint of this steel plate. This is the steel face plate, right? It's the midpoint of this plate to another midpoint of the other plate. Alright, so the D itself is taking in T, alright, T plus C, alright, because half T plus half T plus C, right, the C distance. Okay, I think you get what I mean. This C distance, this is the core of the thing, is 17.5, right? So half of the T, alright, half of this thickness is 0.5 divided by 2, so it's 0.25 mm, right? So I think you get what I mean. So so therefore D is equals to C plus T is equals to what? 18 mm. Okay, so hopefully you are clear. I'm just finding this distance, that's all. Okay, later on I will need it. So you need to memorize how to label these things in a diagram. Okay. And also H. Alright, you need to find H. H is equals to what? The total distance. Alright. So it's the this thing plus this thing plus this thing. Alright. So in other words, this is actually 2t. Maybe I should write as C plus 2t as equals to what it would be. Yeah, it's 18.5 millimeter. Okay, so I have fully labeled all this stuff already. Alright, and later on we'll need to we'll carry on to know what are the things. So we just need to label all this first. Alright, and you may need to find this so-called what are they? These Young modulus, these values, alright, from a table. So a table will be given, and then you may want to find maybe polyethylene, what is the Young modulus? For the steel, what is the Young modulus? Nonetheless, you also want to memorize it if in case that you need it. Alright, take note of this 160 is it? Yeah, it's 160 gigapascal, 210 gigapascal. Okay, you should take note of all these values. Alright, your Young modulus can be also found by using other formulas. You may come to your reading material, page 42 or around that area. You should find that you see there is Young modulus in the one direction, Young modulus in whatever. So if let's say your face is a composite, alright, now our face is actually a simple what? Simple steel plate. Alright, so we no need to do some composite calculation. Alright, but if let's say your face is a composite, you need to know how to calculate all this by using this type of things, your Young modulus. You may need to calculate your Young modulus. Alright, nonetheless, you may also need to know, maybe if let's say they give you Poisson ratio, alright, different Poisson ratio and one of the Young modulus, you may need to use this type of equations to calculate Young modulus in E2. Okay, so you may be given E1, then these are the two Poisson ratio they given, then you may need to calculate E2 to calculate for E2 lah. So these are the formulas that you want to also memorize inside your heart, unless the exam give you. And yeah, you should go and search for this file and check it out lah. Yeah, so this Young modulus, you should take note of the different variations that may come about. Alright, so the type of table will be like given to you like that. So it will give you density, compressive strength, etc. So you may want to take a little time to actually take note of how to convert it to a Young modulus. Or Young modulus is given already, polyethylene, but maybe sometimes it's not given, so you may want to know how to acquire the values. I'll not go through in this video. I'll let you go through yourself in the times to come. So yeah, and before I go into the next video, I also want to introduce you with three. In fact, it's not unfamiliar to you. It's something that is already, I assume, in lecture 7. Alright, lecture 7 you can go like v7 point something, you can watch from there. So the question asks us to find what will be the body and the shear stress. So normally the body, I think it's bending. Never mind. I think it's bending. So you will need to know how to calculate your bending stress. So these are the bending stresses that you need to calculate. Your bending stress in the face and bending stress in the core. Alright, this white color is the core, the face are the steel face. So you need to know how to calculate. And you also want to know how to calculate your shear stresses, which is all these things. Alright. Nonetheless, this one is the maximum deflection. You may want to know how to calculate also. So to save my trouble in explaining all this, alright, in the next video I'll explain this in the next video. Alright, because if I explain here, next video I explain again, no point, right? So I think next video I explain everything. But I just need to know that for bending stress, these are the formula, shear stress, deflection. So I've made them easy for you to see. So next video we'll talk about how to calculate all of them. Alright, so see you there.